In 1933, Einstein left Germany and never returned. His books were publicly burned, and a bounty was reportedly placed on his life. The most celebrated physicist on Earth had become a Jewish refugee, fleeing the nation that once claimed him as its greatest mind. His escape, and the decisions that followed, would change the course of science and world history. But the full weight of what one letter set in motion would haunt him for the rest of his life. In June 1902, Albert Einstein began work as a technical expert Class 3 at the Swiss Federal Office for Intellectual Property in Bern. Earning 3,500 Swiss francs a year, he evaluated mechanical and electrical patent applications in Room 86. Far from a sign of academic failure, this stable desk job provided the structured hours and quiet mental space he needed to conduct independent theoretical research. In 1905, while still employed at the Patent Office, he published 4 papers in the journal Annalen der Physik that shook the foundations of science. He explained the photoelectric effect through discrete packets of light, proved the physical reality of atoms using Brownian motion, and introduced special relativity by showing that space and time adjust to keep the speed of light constant. His final paper that year established mass-energy equivalence, originally calculated as delta M equals L over C squared. This relationship, later simplified to E equals M times C squared, was a fundamental description of nature and did not serve as a prediction for the atomic bomb. In November 1915, Einstein presented his final general relativity field equations to the Prussian Academy, proposing that gravity is described through the geometry of space-time. Under this framework, the mass of the Sun alters the apparent path of nearby starlight. This prediction faced its physical test during the total solar eclipse of May 29, 1919. 2 British expeditions sought to measure the light deflection: Frank Dyson's team in Sobral, Brazil, and Arthur Eddington's team on the island of Principe. They aimed to determine if the deflection matched the Newtonian half-value of roughly 0.87 arcseconds, or Einstein's larger prediction of 1.75. Despite difficult weather-limited conditions and later methodological reservations about the precision of the photographic plates, the teams reported results supporting Einstein. In November 1919, the press seized on these findings. Sensational headlines declared Newton's ideas overthrown and the new theory proven, instantly transforming Einstein into an international celebrity. While physicists understood the observations were a preliminary step, rather than a final proof of every cosmic detail, the public saw only a spectacular scientific revolution. This sudden global prominence made Einstein a primary target for the rising tide of nationalism and anti-Semitism in the 1920s Germany. Nobel laureates Philipp Lenard and Johannes Stark, along with physicist Ernst Gerke, led a coordinated campaign to discredit his theories. They rejected relativity not with mathematical proof, but by labeling it Jewish physics, a politically charged term designed to frame theoretical physics as foreign and untrustworthy. Through pamphlets, public rallies, and articles, the advocates of this Deutsche Physik movement sought to strip Jewish scientists of their positions and legitimacy within German academic institutions. By replacing empirical debate with racial ideology, they transformed a scientific disagreement into a campaign of personal and political exclusion. Adolf Hitler's appointment as chancellor in January 1933 turned academic hostility into official state persecution. On March 28, 1933, while traveling aboard the ocean liner SS Belgenland, Einstein made his final break. Upon docking, he walked into the German consulate in Brussels, surrendered his passport, and formally renounced his German citizenship, retaining only the Swiss nationality he had held since 1901. That same day, he mailed his resignation to the Prussian Academy of Sciences, which the institution formally accepted during its plenary session 2 days later. The new regime retaliated swiftly. Authorities confiscated his bank accounts and seized his personal property, including his Berlin apartment and his summer cottage in Kaputh. Weeks later, on May 10, Nazi-led students threw Einstein's scientific writings onto a massive public bonfire at Berlin's Opernplatz. After spending a tense 6-month period of exile under police protection in the Belgian coastal town of De Haan, Einstein sailed for the United States. In October 1933, he settled at the newly established Institute for Advanced Study in Princeton, New Jersey. The quiet campus offered an institutional home to continue his work, but it remained a refuge born of absolute political exile. In the summer of 1939, Hungarian physicist Leo Szilard realized that recent discoveries in nuclear fission meant a chain reaction could release unprecedented destructive energy. Terrified that Nazi Germany might harness this science to build a new class of weapons, Szilard sought a way to alert the American government. But Szilard lacked the public stature to command the attention of the White House. He turned to Albert Einstein, whose global reputation carried unmatched moral and intellectual authority. On August 2, 1939, Einstein read Szilard's draft and signed his name to the warning letter addressed to President Franklin D. Roosevelt. The act was a grave ethical decision rather than a technical contribution to weaponry. Einstein lent his signature to sound an alarm, fearing the consequences if the Nazi regime unlocked the power of the atom first. Alexander Sachs, an economist and informal advisor to President Franklin D. Roosevelt, carried the letter to the White House on October 11, 1939. He read it aloud to Roosevelt, highlighting the danger of a German monopoly on uranium weapons. Roosevelt responded on October 19th, authorizing the creation of an advisory uranium committee to investigate the military potential of nuclear fission. This initial government response was a small, cautious review. While the letter catalyzed early American interest in uranium, the Manhattan Project itself grew from independent factors. That full-scale industrial effort only began in late 1942, driven by worsening wartime pressures and separate intelligence reports. Throughout this entire process, Einstein remained entirely on the periphery. Due to his pacifist views and political activism, the government denied him security clearance. He did not participate in the technical development of the atomic bomb. His role began and ended with his signature on the page. The destruction of Hiroshima and Nagasaki in 1945 brought Einstein immediate, lasting anguish. He watched the consequences of the atomic age unfold from Princeton, carrying the heavy weight of his signature. In a 1946 interview, Einstein offered a retrospective reflection on his decision, stating that if he had known the Germans would fail to build an atomic bomb, he never would have signed the letter to President Roosevelt. He called it the one great mistake of his life. Near the end of his life, in a November 1954 letter to chemist Linus Pauling, he clarified that his only justification was the danger that Germany would make it first. This quiet remorse reshaped his public mission. On October 1, 1940, Albert Einstein became a citizen of the United States. This legal identity did not erase his Jewish heritage. Instead, it provided a secure platform for his growing public advocacy. Einstein supported the American Civil Rights Movement, joining the NAACP and backing anti-lynching campaigns. In May 1946, he traveled to Lincoln University, a historically black institution, to deliver a commencement address. He spoke plainly, calling segregation a disease of white people, and declaring that he did not intend to remain quiet. He also offered to testify as a character witness for W.E.B. Du Bois. In November 1952, Prime Minister David Ben-Gurion formally invited Einstein to become the second president of Israel. Einstein declined, explaining that he lacked the practical experience and aptitude to govern, choosing instead to remain dedicated to his scientific work as an independent, outspoken citizen. While Einstein focused on his final years in Princeton, the equations he left behind became the foundation for modern cosmology. Later, researchers used his theory of gravity to construct models of an expanding universe, mapping how galaxies drift apart over billions of years. His mathematics also predicted black holes, collapsed stars with gravity so intense that not even light can escape their pull. Decades after his death, scientists proved another of his calculations by detecting gravitational waves, the faint ripples in space-time caused by distant colliding stars. These modern discoveries were made by others using his formulas, proving that his theoretical map still guides our understanding of the cosmos. Einstein's mathematics found a direct, practical application in the global positioning system. Every GPS satellite orbiting Earth must account for both special and general relativity to function. Because the satellites travel at high speeds, special relativity dictates that their onboard clocks run approximately 7 microseconds slower each day. Meanwhile, because they orbit where gravity is weaker, general relativity causes those same clocks to tick about 45 microseconds faster per day. This creates a net discrepancy of roughly 38 microseconds per day. Without automatic adjustments based on these calculations, positioning errors would accumulate by several miles within hours. Engineers applied Einstein's predictions to make the system work, long after the physicists proposed them. The departure of Albert Einstein was the most visible point of a vast, systemic exodus that emptied European institutions of their leading intellectual talent. Throughout the 1930s, thousands of Jewish and politically vulnerable scientists were forced from their positions under discriminatory state decrees. This was a forced exile carrying an immense personal and professional toll. These displaced scholars carried their specialized expertise to universities in their adopted countries, rapidly accelerating the scientific capacity of the United States. In 1935, physicist Hans Bethe immigrated from Germany after the regime stripped him of his position at the University of Tübingen. Settling at Cornell University, Bethe pioneered the theory of stellar nucleosynthesis, mapping how stars produce heavier elements, before lending his expertise to wartime defense projects. Similarly, Leo Szilard left Europe in 1933, eventually securing a research position at Columbia University to continue his work on nuclear chain reactions. This massive transfer of intellectual wealth reshaped American higher education. The arrival of these and hundreds of other émigrés filled university laboratories and classrooms with world-class faculty, permanently shifting the global center of scientific innovation across the Atlantic. Einstein's journey reminds us that genius knows no borders, yet humanity continues to erect them. Today, the free exchange of minds remains the engine of scientific progress. The lesson he left us is clear. When societies exile intellectual freedom, they discard their own future. What do you think of his legacy? Share your thoughts in the comments.